Let's take a look at question number 5. We have coordinate geometry planes question. In this question, they give us 3 planes equation with 2 unknowns, P and Q. They tell us that these 3 planes form a shift and they want us to find the unknown values for P and Q. Let's start by imagining how does a shift look like. Okay, so we have one plane here. And then we will have another. Okay, so at the back, go to the front. Okay, and what we don't see is like go slightly like that and it's passing through this plane. And then we also will have another plane this side. Okay, and it goes like that. So this plane is also passing through this line. So a shift happens, okay, when all 3 planes passing through one common line. So instead of having a point of intersection, what we have here is a line of intersection. So what does it mean by having one common line? So that means we have infinitely many solutions. Okay, let's write down our coefficients for all these 3 equations into matrix form. So M is equal to 2, negative 1, 1, 1, P, negative 3, 3, 1, negative 2. So when we have infinitely many solutions, that means we have a singular matrix, which means determinants of M is equal to 0. How do you find determinant for a 3 by 3 matrix? You start by writing plus, minus, plus. It belongs to the first row. So that's what I'm going to write. I'm going to write plus, minus, plus. And then I'm going to write down the elements from the first row. So here I'm going to have 2, negative 1, and 1. Next, let's take a look at 2. So what I'm going to do now is I'm going to close its column and its row. Then I will write down the balance matrix. So it will be P, negative 3, 1, negative 2. That's it. Okay, moving on to the second column. Okay, I'm going to close this column and this row. So I'm left with 1, 3, negative 3, negative 2. We'll do the same thing to the last element. So we're going to close the last column and the first row and we will get 1, 3, P1. This will equal to 0. Okay, what happened now is we have to find the determinant for each 2 by 2 matrix. So it would be 2. This one would be negative 2P minus negative 3 plus 1. Here would be negative 2 minus negative 9 plus 1, 1 minus 3P. So this is equal to 0. So what we have here is this 2, negative 2P plus 3. And here it will just be, okay, negative 2 plus 9, which is 7. Plus 1 minus 3P equal to 0. Let's expand the first part. Then we'll get negative 4P plus 6 plus 8 minus 3P equal to 0. Let's bring all of our unknown to the right hand side. So we will have 14 equal to 7P. P is equal to 2. That's it. We are done with part 1. Moving on to part 2. Okay. Now we want to find the value of Q. But before that, let's fill in the blanks, our value of P. So we will have new equation. So 2x minus y plus z equals to 3. X plus, okay, what is our P value? 2. 2y minus 3z equal to Q. 3x plus y minus 2z equal to 4. Now that we have 3 equations, okay, what we can do is we can use simultaneous equation to solve for Q. What we're going to do next is we can figure out how to eliminate y. So let's start by adding 1 and 3. So what I would like to do is adding 1 and 3. Equation 1 and equation 3. So I will have 2x minus y plus z is equal to 3. Here I'll get 3x plus y minus 2z is equal to 4. If I add these two together, I will get 5x. Y will be eliminated. Okay, minus z equal to 7. Let's take a look. Okay, we have to find a different combination to eliminate y, but it must include equation 2 now. So what I would like to do is, okay, to multiply by equation, oh my bad, to multiply by equation 1 plus with equation 2. So let's multiply 2 to the first equation and I will get 4x minus 2y plus 2z is equal to 6. And then equation 2, I'll get x plus 2y minus 3z equal to q. I will add these two equations and I'll have 5x. The y will be eliminated. Minus z equal to 6 plus q. Notice that we have the same left-hand side for both equation. So what I can do is I can write it this way. So 5x minus z is equal to 7 equal to 6 plus q. Therefore, 6 plus q is equal to 7. Q is equal to 1. With that, we are done with this question. So P is equal to 2, the answer for part 1, and Q equals to 1, the answer to part 2.